All right, let's go ahead and look at this performance event practice. For the first part, you're looking at more of like an experimental design setup type of thing. And what you're going to want to do here on the EOC is to make sure you read the paragraph that you're given fully and take note of some important parts. So let's go ahead and read this real quick. You've been hired by Bass Pro Shops to perform a study for their freshwater fish tanks. They're wanting to install large outdoor tanks and are concerned about the survival of the fish populations as the oxygen levels in the water change with temperature in the warmer climates. Previously, they have always kept their tanks at 55 degrees Fahrenheit. The point of this study is to investigate how certain oxygen levels affect the size of a fish population. If the study provides evidence that oxygen levels can affect population sizes, then they will consider investing in installing expensive units on their tanks which will provide temperature control capabilities. To aid in the study, you have been provided a lab with 6 full-scale prototypes of the tanks which will be used, as well as fertilized eggs of each of the species which they intend to stock. Okay, so first thing that you'd want to do is try to figure out what exactly the purpose and point of this experiment is. And they tell you that the purpose here is to investigate oxygen levels and fish populations. So right there, we know what our two variables are going to be that we are studying. We're going to be looking at fish populations and oxygen levels. Okay, so to construct a hypothesis, first thing you need to do is determine what the independent and dependent variables are, because that's the way that you set up your hypothesis. So independent variable needs to be the cause. It's going to be what the overall cause of the phenomenon that we see happening is going to be. And in this case, we are seeing how oxygen levels affect fish populations. So our independent variable, the cause, is going to be the level of oxygen. Then our dependent variable is going to be what depends on the oxygen level, which is going to be fish populations. So that will be our dependent variable. So when you construct a hypothesis, it should always be in an if-then format. It needs to be if, and then something about the independent variable, then something about the dependent variable. So one that you could have chosen here is if the oxygen levels in the tanks are increased, then a larger fish population will be seen. Now you could have approached this hypothesis from either side. Remember that a hypothesis should be done before the study is actually finished, so you wouldn't have the results before you make the hypothesis. So that's what you should do here as well. As we already said, the independent variable in this case has to be the oxygen level, which makes the dependent variable the fish populations. Some constants that you need to be maintained. Constants are conditions that have to be set and controlled throughout the experiment to ensure that you are not altering the results. You can only test one dependent variable at a time, and any time that you change between any experimental groups or even the control group, any conditions from one to the next, you've now introduced a new dependent or independent variable, and we don't want to do that. So anything that deals with the conditions inside the tank, so the pH of the water, the fish species that are being used, the size of the tank, any of those things would need to be controlled. There's a lot of options here. Experimental groups. So in this case, we have, I think it is 4 different experimental groups, and it's just going to be any group of it's any fish population that is observed at a temperature other than 55 degrees, because it says in here that usually Bass Pro keeps their fish tanks at about 55 degrees Fahrenheit. So any temperature outside of that is going to be an experimental group. The control group then is that usual 55 degree group, the fish population that we see there.